Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials version 6 course, or the Networking 2 course at Anne Arundel Community College. And this morning, or actually this afternoon's Packet Tracer tutorial and solution set is going to be on Lab Activity 2.2.2.5, where we take another look at IPv4 static and default routes. And I can't stress enough how important it is to have a mastery of static and default routing, not only for certification purposes, but more importantly, in the real world. So remember, this is not a packet tracer activity per se. You're going to have to build this from scratch in Packet Tracer. So let's dive in and make that happen right now. So here is our blank palette. We're going to come down here to devices, right? I'm simply going to click on network devices, and then I'm going to be shown a series of devices from which I can choose. Now we're going to grab 2911s. Where are the 2911s? There they are. So we're going to grab 2911s. I'm going to put two 2911s out here. I'm going to make this larger in just a second, don't worry. And we're going to need two switches. So I'm going to come down here to switches on the bottom, right? You can see switches, Control-Alt-S. And what is this lab calling for? I believe these are 2960s we should be good with. And I'm reading, yeah, 2960s is going to work. So there's one, and there is two. So 2960 TTs. And we also need some hosts. So let's grab a generic PC and then another generic PC, and that is going to make up the entirety of our topology. So now let's try to clean this up a little bit here. And we'll put these guys here and then the switches underneath, relatively close. And again, I'm going to be expanding the size of this here in a second. We'll put one PC there and one PC here. So basically what we're doing is we're taking a lab that you would do in class, if you were taking this class in person. And let me turn off all this music coming through. All right, so now what we need to do is now we need to interconnect the devices. So we come to the lightning bolt tab down here, and that is where our connections reside. So you can see we've got some serial connections, and we're going to do a serial connection from here. But what's the problem? Exactly, remember, in Packet Tracer, the devices do not come with the connections all ready to go. So what we need to do is we need to actually pull the device up. The little power tab right there, we're going to click off. We're going to come to the HWIC2T, and we're going to drag and drop one over there. And yeah, serial 000 and 001. And then I'm going to turn this router back on. Right, so that was router 0 that we have over there. Here's router 1. And we're going to power it off with that little power tab. We're going to grab an HWIC2T card and drop it in the rightmost open slot of the 4 open slots that are there. And then we are going to power that router back on. Now let's do this here. So the way that you make your icons larger is Control-I. Right, I'm holding down Control. I'm on a Mac. I'm holding down Control and hitting I. And that enlarges things for us. So now let's come back and let's do this and see if we can go from serial 001 over to serial 000. And we can, and the DCE DTE, you see the little designator there. That's sort of a legacy thing. It's not really relevant here in our configuration here. So we've got our routers connected. Let's grab some straight through cables, and we're going to go from FA05 up to, what are we doing? Gig 01. And then we're going to do a straight through cable again from FA05 and fast Ethernet 05 up to Gig 01. And then we are going to connect the PCs with a straight through cable, and simply going to be fast Ethernet 0 on the PC up to fast Ethernet 06 on the switch. And I think we're going to be leaving everything in VLAN 1. And so I think we're going to be good. All right, so that is what our topology looks like. Oh, I'm sorry, that's actually not correct right there. Let me pull that off of there. It's supposed to be, so it's 6 on one side, and for some reason they've got it in fast Ethernet 018 over here. So I made the mistake that they would make it easy for us. All right, so there we go. Now we've got some red lights here, clearly some connectivity issues, and we're going to sort through those in turn. Now the addressing table for this activity. Let's go ahead and hop on, and in fact, before we do that, let me do this. So if I come to the attributes, not the attributes, the config, the display name is going to be R1. Right, we'll try to make this a little bit easier, and we'll go to the config here in the router. This is R2. And if I come over here to the switch, we can go to the config, and the switch is S1. Whoops, S1. And to ensure that there's mass confusion, and that's just a little joke right there, instead of switch 2, this is switch 3. And actually, I got the router wrong as well. So let's go back and get that. It's router 3. All right, so there is mass confusion. All right, switch 1, switch 3. And the PCs, it's just going to be PCA. And we'll save that. There we go. And PC, let me guess, it's got to be C, right? Yep, PCC. Well, at least they're consistent about being inconsistent on this config here. All right, so we are set up. Let's dive into router 1. And let's get on the CLI, and you can see the configuration is blank, right? So let's make this happen. Let's get into privilege exec mode and then right into global config. I'm going to say hostname R1. We'll get the hostname set up. I'm going to say no IP domain name lookup, because I want to make sure that if I type something wrong, we don't end up waiting for it to try to resolve the hostname. And then let's get right into those interfaces. So we're going to start with Gigabit Ethernet 01. I'm going to say no shut. You can see it brings that interface state to up, but now we need to put an IP address on here, 192.168.0.1, and it's a /24. Then we're going to get into Ethernet serial 001, and we're going to say, whoops, no shut, IP address 10.1.1.1. And they give us the dotted decimal subnet masks there. And so for right now, that is going to be it. And you can see that we look good. We've got green lights on here. In fact, I'll jump down to the PC here, and we'll be able to test some connectivity. So remember, that's that gig 01 interface right there. So I come to the PC, and we're going to put a static IP on here. It's 192.168.0.10. Subnet mask is correct, and our default gateway is going to be 192.168.0.1. Remember, it's that gig 01 interface on router 1. That is my default gateway. And let's see, can I ping my default gateway? 192.168.0.1. Outstanding. All right, let's get on router 3 and add our configuration information in for router 3. And we're leaving everything on VLAN 1, so no switch configuration here. So from user exec with the enable command to privilege exec into global config. And we're going to say hostname R3. We're going to say no IP domain name lookup. And then right into our interfaces. So the first interface is Gigabit Ethernet 01. We're going to say no shut. IP address is 192.168.1.1, 255.255.255.0/24, and then serial 000, where we're going to say IP address 10.1.1.2, whoops, .2/30, no shut. And I should now be able to ping 10.1.1.1, which is the interface, and there we go. So we have connectivity across the interfaces, or across the serial links, the point-to-point serial connections. Okay, now, when you look at this diagram, and Lauren actually had this question about these loopback interface. How do you configure a loopback interface? Well, when you look at the diagram, right, it just shows those two lines coming off of it as if it's a LAN segment. Remember, a loopback interface is a logical, virtual interface. It doesn't physically exist on the router. It virtually exists on the router. And one of the great and many uses of the loopback address is to simulate an internet or a network, right? So we use it in this case with a 209 and a 198. Those are both publicly routable IPs. And so the reason we're configuring those, or these loopback addresses with those IPs, is because what we're ultimately going to do is we're going to pretend that we're going to the internet by using those IP addresses, right? So we configure them on the router, and then we simply use them as if we were going to the internet. So we're simulating what's going on. All right, so let's hold on here. All right, so we can ping the interface on the other side. So that's router 1's interface. And now let's go ahead and continue on the configuration here. And I'm actually looking over at the document to make sure we've got everything so far. Okay, so the loopback interfaces, that's what we need to do next. Now, so here's why we configure those loopback interfaces. So I'm going to go ahead and say interface loopback 0. And you can see the interface is up. And in fact, loopback interfaces are always up unless you shut them down. And you can shut down a loopback interface with simply the shut command or the shutdown command. So I'm going to say IP address, and we're using these again to simulate 165.200.225, just a host that's out there on the internet. And here is the subnet mask, 224, I believe. Is that right? Yes. And then we're going to go into interface loopback 1. And we're going to say IP address 198.133.219.1, and it's a /24. Now, another fantastic use of loopback addresses is for management of devices. In a lot of cases, you'll see the loopback address being used as the management IP address. So we'll say do show IP interface brief. And there we go. And as you can see, we've got the two loopback addresses. Now, they don't show up here, and that's fine because we know that they exist right there. Now, we've already configured PCA. Let's configure PCC, and we'll jump right in here. And PCC's IP is 192.168.1.10. It's a /24. And what is the default gateway? It's the router. Remember, the router is going to be the gateway for us here, 192.168.1.1, and it's router 3. No DNS required here, right? So let's go ahead and see. Can I ping 192.168.1.1? Absolutely. Can I ping PCA right now? What do you think? 192.168.0.1? Or no, sorry, not 0.1. So, but it doesn't matter. So we did 0.1, which is router 1's interface, and even if I did 10, which is the correct designator there, we get destination host unreachable. And we saw this in a previous activity. In fact, remember, it's the destination host unreachable message that we get when, in fact, the router, and that's 192.168.1.1, remember, reply from 192.168.1.1 is basically saying, hey, router 3 is telling you, dude, I have no idea how to get to the network that you're going to. I've got no information that's going to help me get there. And so that is the premise of this lab. It's to go ahead and make sure that we get that information set up. Now, step 4 in the lab, it asks to test connectivity from pinging from each PC to the default gateway. We did that. So A can ping its default gateway, C can ping its default gateway. So then step B, or I'm sorry, sub-step B in step 4 is test connectivity by pinging the directly connected routers. We did that. That works. What about between the PCs? No. PCA to the loopback addresses out on router 3, same thing. They're not reachable. Destination host unreachable. Again, if I pull PCA up here and I were to say, let's ping that simulated internet address, which was 209, I think it's 165. Let me pull that back up here. I've got this document over here. I'm scrolling up and down. 209, 165.200.225. And we get what we suspect or that we should be able to guess at this point we're going to see. It's that I don't have router 1 saying I don't have routing information to get you to that destination. All right, so we wanted to gather step 5, gather some information. Check the status of interfaces on R1 with the show IP interface brief command. We kind of already did that. How many interfaces are active? Well, let's see. Show IP interface brief. We've got 2 interfaces, the serial interface as well as the gigabit interface on router 3. We did look at router 3. In fact, it's right there. Now, we've got 4 interfaces here. Remember, the 2 physical interfaces on the router, and then the 2 logical or virtual loopback addresses that are basically nothing more than software addresses, right? This is all being done in software, right? It's virtual. Okay, so view the routing table on R1 with a show IP route. Let's pull router 1 up here, and we're going to say show IP route. And we see that we've got 2 directly connected along with the, hold on a second, the addressing table, okay, good. Just the 2 directly connected in the local entries. View the routing table information from router 3. So what routing, it says what networks are present in the addressing table in this lab, but not in the routing table for R3. And then the same question was for R1. Well, we know that on router 1, we don't have the network over here or the loopback interfaces for router 3. And on router 3, we don't have this network over here that's behind router 1, right? And so we would need to add that information in. So why are all the networks not in the routing table of each of the routers? Well, because we're not running a dynamic routing protocol here, and we haven't manually configured the entries that are going to be required. And therefore, again, remember, the routers, we have to tell the routers what it is they're doing. We can't just simply hope that they're going to figure out what that routing information is. So we've got to either configure it with a dynamic routing protocol or manually. And this lab is all about the manual creation. So we're going to create a recursive static route. And the next top IP is specified. I'm just reading through here real quickly. So on router 1, we're going to configure a recursive static route. Let's get into global config here. Over to the network behind router 3, the 192.168.1.0/24. So remember, my IP route to get to the 192.168.1.0/24, but we have to use that dotted decimal notation for the subnet mask, is going to be going to the next hop address of, it's going to be that interface right there, which I don't remember the address on, so it'll be easier for me to look at it here. Yeah, 10.1.1.2. So let's pull that back up. So 10.1.1.2. So 10.1.1.2. And write the command used in the space. So this is the command right there, and so we enter that command in. It says verify the routing table and verify the new static route entry. Sure, do show IP route. And there it is, right? So how can we verify that that entry works? So what if I ping from PCA over to, over to PCC? Is this going to work now that we have a route on router 1? And it does. And hold on one second. I'm not certain that that should have worked. We should have had to have had 2 entries in there. Wait a minute. I'm sorry. I just pinged myself. Oh, the brutality sometimes. So there we go. I ran the ping command, and I'm like, wait a minute. That should not be working right now. And that is what we would, this is what we expect to see, is request timed out. So when you ping the right IP address that you're trying to get to, right, that you should not be able to come back from, because we need 2 static routes. That was one of the questions out of the packet tracer activities. So can we ping? And the answer is no. We cannot ping because R3 doesn't have a route to bring us back from the LAN that's behind router 3. So Here's what we're going to do. Step 2. We're going to create a static route to the router 1 subnet, or the PC1 LAN, PCA LAN, and we're going to use the exit interface. So we're going to use the directly connected interface in the routing statement. So it's not going to be recursive. We say IP route. So my route to get to the 192.168.0.0, now this is /24, so 255.255.255.0 is out serial 000. And there is that very common message that we see, not an error message, but just a warning letting you know that if it's not a point-to-point interface, you could have a performance hit. And that was the command that we used to create that. It says verify the static route, do show IP route. And where is it? It is right here. There is my directly connected static route, and it's listed in the routing table just like that with an S for static. Now from host A, I've got a much better feeling about this, and we've got the right address in there for PCC. It works because now the traffic can not only get to PCC, but it knows how to come back, right? And that is critical. The ping should be successful, and it is, so we're going to configure another static route, and this is going to be to, let me say, do show run. I need to see these loopback interfaces to get the, I think I went right by them there. And there they are, to get the subnet mask. So /24 for the first one. All right, so on router 1, we're on step 3 now under part 3. Step 3, part 3 on router 1, configure a static route to the 198.133.219.0 network using one of the static route configuration options from the previous step. So we kind of get to pick what we're going to do here. So I'm going to say IP route. So my route to get to the 198.133.219.0, and it's a /24, is out serial 001. And do you show IP? Yeah, that's right. Yeah, serial 001. All right, so with that configured on PCA, if I try to ping that 198.133.219 dot, and what is that exact .1, okay? .1. It works because now the traffic going through router 1 knows how to get there, right? We just send it out the serial 001 interface. And router 3 already knows about the source network here, that PCA is the ping, right, coming from PCA. Router 3, we put a static in 3, and it knows how to get back, so it works, right? And again, the loopback is doing nothing more than simulating a quote-unquote internet presence of some kind. All right, so on router 1, we're now going to configure a static route again, and we're going to set this one up as, so my IP route to get to the 209.165.200.224, oh, it's not 224, yeah, 224, and I think that was the subnet mask as well. I'm going to have to check that again. Yeah, so it was a 224, so it's a /27. Let's work that out in my head here real quick. So we're going to, it's a .224, which means in this last octet we're borrowing the first 3 leftmost bits to become network bits, because 128 and 64 is 192 plus 32 is 224, and so 224 is our subnet mask here, and I'm going to do it the same way if that's okay. Let's see what it says. What does it want us to do here? Using the other static route option. All right, so we're going to use the other option, which is to use the IP address, right? So the recursive one we've just done here. We did the directly connected before this. So view the routing table. Do show IP route. Are they in there? They are. Here's the first. Whoops, sorry. I'm trying to highlight the wrong thing here. Here's the first directly connected one to the 198 network. And then here's my static to the 209 via the next hop IP. So we already pinged the 198, and that should work. And now let me go ahead and ping the 209.165.200.225 where we're using, and there we go. and it works. All right, so now it says remove static routes for the loopback addresses. On router 1, use the no command. So let me pull this out here, and we'll say no, and then we'll remove this one here by saying no. From the routing table, write the commands used in the space provided. So those are the two commands right there. You just simply say no, right? And then give the command that you originally issued. Now, view the routing table to verify the routes have been removed. Do show IP route. Are they gone? Absolutely. We no longer have a route to the 209, and we no longer have a route to the 198. So how many network routes are listed here? Well, we've got the 2 directly connected, the 2 local, and then the single static to the R3 LAN. Is the gateway of last resort set? Do I see a candidate default? Anybody here with an asterisk next to their designator? And the answer to that is no, there is no candidate default here. Now on to part 4, we're going to configure a default route, right? Because if you think about it, it makes sense from router 1's perspective. Router 1 has a single path to get to the loopback addresses and to get over to the LAN behind router 3. It's out that serial 001 interface. It's the only way traffic can go from PCA's LAN out over here to the loopbacks that are off of router 3 and the PCC LAN. So let's create a static route. This is a great use case for that static route, and we'll do the quad 0, 0, 0, 0, 0. And let me see how they want us to do this. Exit interface. All right, 001. That's the command that we used in the space. How is it listed? That's a command that we used in the configuration that would be filled in the space. Do show IP route. And you can see that's how it's listed as a candidate default static route. It's got the little asterisk next to it. And the gateway of last resort is, in fact, that serial 001 interface, right? That's where it's going to be. All the traffic we don't know where it's going to, or that we don't have a longer, more specific match to get to in the routing table, we're going to use our default gateway. So now let's reping 225 and it works, right? And we'll reping the 198 and it works as well. Now to the reflection questions. So a new network is connected to the gig 00 interface on router 1. What command or commands could be used to configure a static route to that network from router 3? So here's what we could do. We could say this. I could say IP route. So again, my route to get to the 192.168.3.0/24 is out my serial 00 interface. Or I could say it's the next hop 10.1.1.1. Or I could say it's out the serial interface and fully specify it like that. And it doesn't like that. I can never remember if it's the, and then serial 000. Yeah, it does. The packet tracer isn't liking that. So, but that's the fully specified. It should be this first one here with the serial. So we could do it one of 3 ways. Is there a benefit to configuring a directly connected static route instead of a recursive static route? And the answer to this is yes, if you've watched any of the previous videos. And the reason for that is because the routing table only does a single lookup for the directly connected piece. And the recursive static route is going to require 2 lookups. Now, why is it important to configure a default route on the router? And this is a very, very important point. If you don't have a default route on the router, and we'll use router 1 as an example, if there's no default route on router 1, if it doesn't have a specific match for the network that PCA, let's say, is trying to go to, what is the message I'm going to get back from router 1? Destination host unreachable. Because remember, and let me get my pen here, I was drawing with a mouse there. So remember, the guy or gal that's working on PCA here, right, who says ping, and I'll make up a different address, 75.31.3.7, right? And that ping packet comes up here to router 1 because the first thing that happens is the PCA looks at its network table and says, nope, I have no clue how to get to that, but I have a default gateway configured. So I'm going to send that traffic to my default gateway. So it looks at what we configured as the default gateway, which was the address right here, 192.168.0.1. And it sends this packet, and the packet shows up here with a source and destination. The source being PCA is our source, and the destination is this address right here. And that's when router 1 does what routers do best. It looks into its RIB, its routing information database, its routing table, and it says, do I have a match, a network statement that matches that destination? And if so, where do I send it? And if it's not there, it's going to respond back just like we saw early on in this activity. It's going to respond back if it's not there and say destination unreachable. So a default route serves the purpose of a safety net as a catch-all, which means I can have static routes, one that points over here. I could even have a static route that points to those loopback addresses that are over here. But it doesn't really make sense in this design right here. The only thing that I need is a default route that says send all traffic that I don't have a longer, more specific match for. Just fire it out that interface over here to router 3. I'll let router 3 deal with it. And you won't get a destination unreachable, right? Because the packets will be forwarded along. You may get a request timeout if those networks don't exist, but you certainly won't get a destination unreachable at that point because the default route matches all IPv4 networks, all of them. And that's why it's the default. All right. So we've covered pretty extensively here, default routing, recursive routing, static routing, all kinds of different things going on. So that is going to be the conclusion of packet tracer activity, or I should say of lab activity. Remember, this is the lab that you would do in class if you were taking this as an in-person platform. So lab 2.2.2.5, which is IPv4 static and default routes. All right, guys, have a great weekend, and I will talk with you soon.